Hello, pre-calc ladies and gentlemen. Today we're going to do lesson 13, intersecting secants, intersecting secants and tangents, products of chord segments, and products of secant and tangent segments. We've got a lot of formulas today, which you can absolutely add to your formula sheet. So let's first talk about intersecting secants. Okay, a secant is a line that intersects the circle at 2 points. So that is a secant line. Now, if two secants intersect inside of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the intercepted arcs. Okay, so what does that look like? This is our circle. We have these two secants intersecting inside of my circle. I have this angle here, which is the same as that angle there. They are vertical angles. And if I was to say this is 40, this is 80, x would be the sum of those two arcs, 40 and 80, divided by 2, which gives me 60. Okay, now let's do a quick proof of that. Okay, so I'm going to again draw my circle and my two secants. I'm going to label these A, B, C, and D. This is angle 1. And if I was to draw, that was not very straight. This will be angle 3. This will be angle 2. Now, if we just look at this angle here, it is an inscribed angle. So, the measure of angle 2 is 1/2 of this arc. Okay, so measure of angle 2 is 1/2 the measure of arc AC. And likewise, if we look at this angle here, the measure of angle 3 is 1/2 the measure of arc DB. Okay, we have those there. Now, if I was to look at measure of angle 1, the measure of angle 1 is going to be the measure of angle 2 plus the measure of angle 3. Right? Because I have a triangle that I've drawn there. Okay? And I'm going to plug in what angle 2 and angle 3 are. So the measure of angle 1 is 1/2 the measure of AC plus 1/2 the measure of DB. So if I factor out a 1/2, the measure of angle 1 is 1/2 the measure of AC plus the measure of DB. There you go. Our quick little proof there. Let's move on. Let's talk about our next formula, intersecting secants and tangents. Okay, now before we've talked about what a tangent is, it touches the circle at 1 point. So the measure of an angle formed by two secants, a secant and a tangent, or two tangents that intersects outside of our circle. So if we have an angle formed by either two secants, a secant and a tangent, or two tangents, and all of them intersect outside the circle, this is 1/2 the difference of the measures of intercepted arcs. Okay, so this could look like we have two secants intersecting outside of a circle. Okay, make them cross a little bit. And this is x, this is x. Let's say again this is 80, this is 40. X is 80 minus 40 over 2, which gives me 20. We could also have a secant and a tangent. So here's my tangent, here's my secant, there's my angle x. Let's say this is 60 and 120. Again, x would be the difference, 120 minus 60 over 2 gives me 30. Or if I have two tangents, there's one tangent, there's two tangents. They create this angle here. This is 100, and let's say this is 260. So then x would be 260 minus 100 over 2, which gives me 80. Okay, now there is a proof of that in your book. Okay, if you are interested, you may do that. Okay, and let's do an example just to get some practice. If I have this circle with a tangent and a secant, I say this is x, this is 120, and this is 170. Now normally we want this arc here. Okay, we're trying to find x, but I know the other two arcs, and I know that all of the arcs in a circle add up to equal 360. So I can do 360 minus 170 minus 120 gives me this arc here, which it gives me that it is 70. So then x is 170 minus 70 divided by 2, which gives me 50. Okay? All right, let's talk about the product of chord segments. Okay? The product of the lengths of the segments of intersecting chords they are equal. Okay, so if we have a circle, we have two chords. Remember, chords goes from one side to the other. And let's say I labeled this A, B, C, D. The product of the segments are equal. So A times B equals C times D. Okay, now we can do this a quick proof. So here's my circle, here are my chords, again A, B, C, and D, and I'm going to draw triangles out of them. Okay, now I know that the vertical angles formed here and here are equal because they're both going to the same arc, which is this arc here. So I know that those two are equal. Okay? Can we see that? Yeah. And if those two are equal, okay, I also know that this angle in the middle is equal. So I can say that these are similar triangles, right? If I was to put A, C, P, B, and D, we can say that triangle APC is similar to triangle DPB. And since that is true, I can set up ratios. I can say that A over D is the same as C over B. And if I cross multiply A, B equals C, D, which is exactly what we had earlier. Okay, and let's do an example. If I have a circle and I have my two chords, 30, 40, x plus 10, x plus 20. Okay, so I know my product, 30 times x plus 20 is 40 times x plus 10. Okay, I distribute my 30, I distribute my 40. So 30x plus 600 equals 40x plus 400. Okay, this is a 10. And then I'm going to bring my 30x over and bring my 400 over. So 200 equals 10x, so x is 20. Okay? That is how we would use two chords. All right, moving right along. We have the product of secant segments, a different type. Okay, these are secant segments. We're not talking about the angles anymore. And we can say if we have two secant segments are drawn from a circle to a point outside the circle, the product of the length of one entire segment and its external segment equals the product of the length of the other entire secant segment and its external segment. So all of those words, what do they mean? I have a circle. I have two secant segments that have come into a point. If I call this A, B, C, and D, I have the product of the entire secant length, which is A plus B, times the outer, which is A, equals the product of the entire other secant segment times the outer, which is C. Okay? So let's do an example. I think we're on example 3. If I have this circle and these two secant segments, I have 3x, x, and 3. So I'm going to have x plus 3 times my outer, which is 3, equals x plus 3 times my outer, which is x. Okay, distribute. So 3x plus 9 is x squared plus 3x. Okay, I have 3x on both sides, so those cancel. X squared equals 9. Take the square root, x equals 3. Okay, now technically we know x is plus or minus 3, but we eliminate our negative option because we're not going to have a negative length. Okay, all right, couple more. The product of a secant segment and a tangent segment. Okay, if a secant segment and a tangent segment are drawn from a circle to a point outside, then the product of the length of the secant segment and the length of its external, just like the last one, equals the square, means we're squaring something, not square root, the square of the length of the tangent segment. Okay, so if I have this circle, this is my secant, this is my tangent. If I call this A, B, C, I do the same thing for my secant, my whole times my outer, equals, now in my tangent, my whole is my outer. So I have C squared. Okay, and let's do an example. This will end our lesson. Example 4, we have this secant, this tangent, 12, x, and 8. So we have our whole secant, 12 plus x, times the outer, which is x, equals 8 squared. So 12x plus x squared equals 64. I'm going to bring my 64 over, so x squared plus 12x minus 64 equals 0, which I can factor into x plus 16 times x minus 4 equals 0. So then x is negative 16, positive 4, except we eliminate the negative 16 as an extraneous solution, so we just have x equals 4. Okay? As always, if you have any questions, bring them to class tomorrow, and we will go over them. But that is all for today.